And a Q looks like a K. You know, for example, QC is just G raised to the little g, but rather than using the equilibrium, we plug in the initial. H raised to little h, the initial dot dot dot, A to little a, initial, B to little b, initial. So it looks exactly like Kc, except we don't use the equilibrium concentrations, we use initial concentrations. And so we compare QC with Kc. If QC equals Kc, then what that means is the initial concentration is already in the right ratio. They're already in the equilibrium ratio because K is the right ratio, right? The equilibrium ratio. If QC is greater than Kc, then we have too much product. You know, we got too much product. We got to shift it to the left. And so it would be a plus, plus, minus, minus scenario. If QC is less than Kc, then we don't have enough product. If we don't have enough product, it's got to shift to the right, which is a minus, minus, plus, plus scenario. For our change, we got to figure out what the change is. And here the change would just be 0 because there's no need for any change. So we added there. And so we can just calculate what Q is. And so calculating Q, you know, QC in this particular case is just, you know, the copper 2 plus initial squared tin 4 divided by the copper plus. Actually, is that 2? I screwed this up. It can't be 2 plus. This got to be plus. Copper plus. This is 2 plus down here squared tin 2. So can somebody calculate the Q based on the initial concentrations and see, you know, are the initial conditions too heavily biased towards the product, the reactant, or perfect as is? So it's just 0.2 squared times 0.2 divided by 0.1 squared divided by 0.3. So, does somebody have a Q value? .0266. Is that what other people got? Yeah. Okay. Just want to verify. At least one more person. Which tells me, if I look at this, this would be the product over reactant. And so it says my initial conditions, they don't have enough product. Right? And so the change is going to be minus, minus, plus, plus. So that's how we figure out if it's ever uncertain. And this plus plus minus minus is out. And so now at equilibrium, I'm going to expect 0.100 minus 2x molar, 0.300 minus x molar, 0.200 plus 2x molar, 0.200 plus x. Does that look right? Okay, then what we'll do is we'll just plug it into K and figure it out there. We'll plug this in for here, KC. You're going to get 0.200 plus 2x squared times 0.200 plus x first, divided by 0.100 minus 2x squared, then 0.300 minus x. You look at the math and you go, boy, math looks difficult, doesn't it? This one looks like we're going to have to use successive approximations, or we might try one of our tricks. One of our tricks would be to use the simplifying assumption. And so let's try the simplifying assumption here, because we already know it's going to be kind of 50-50. We know the change shouldn't be very big, right? And so let's try SA, the simplifying assumption. And so in the simplifying assumption, we're just going to assume that 0.200 plus 2x, is about equal to 0.200. We're just going to say, yeah, we're not going to gain much, of this. I'm just looking at these terms here. And then the 0.200 plus x is going to be about 0.200. And the 0.100 minus 2x should be about 0.100. And the 0.300 minus x is about 0.300. So we try the simplifying assumption. And that's going to make the math way easier, right? So we just do the SA. We get 0.200 squared times 0.200 divided by 0.100 squared divided by 0.300. Okay. And then we solve for x. If you try to solve for x, it's going to be simple because there's no x. So we don't. If there's no x, we don't have to solve for x, do we? If there's no x. If there's no x, we can't solve for x. So I'm done. I don't have to do any more because no x. The SA fails. There's no x. Then no x here. So I can't do it. And so that leaves me with one successive approximation. Or there's one other thing that we can do. The one other thing that we can do is to reset the initial. There's two strategies for resetting the initial. One strategy is so that we could follow resetting by the simplifying assumption. The other strategy for resetting the initial is to get rid of some binomials, because the more binomials we have, the more complicated the math. And so even though we already said this is not heavily biased, what we're going to do is, even though it's going to be about a 50-50 mix, we're going to go ahead and reset this. Just to see if that makes the math a little bit easier. And so I'm going to reset it. Now if I'm going to reset it to the right or the left, which one should I pick? I'd probably pick resetting it to the right, because this is greater than 1. And so if I reset this, let's see if it makes the math any easier. So let's, this is still okay. This part for sure is not good, but we can continue with this if we want. So let's try to reset this. Resetting this is going to be minus, what's the limiting reagent here? If we have, we're going to assume 100% forward reaction. What's the limiting reagent? The copper. So we're going to lose all the copper. And so the new initial is going to be 0 molar copper, which means minus y, actually this is minus 2y. Minus 2y is equal to 0.100, minus 0.100. And so 0.100 minus 2y, or 0.100 minus 0.100 is 0. So if we can consume 0.100 copper, how much tin do we consume? this is going to be minus y. And so y is half of it, right? This is minus 0.050, 500. And so we end up with 0.250, etc. We're out of time, so we'll continue this next time. We're going to do lab work.
So for nomenclature, I know that there's a rule that if the whole thing is like positive, that it changes like to 8.
The whole thing is negative.
Negative 8. Yeah. So if it's like chromium, would it be chromate? And then what if it's positive?
No, it doesn't change. You just use chromium.
So what if it's like an ion? Would it be like 8?
No, if it's a negative ion, it's 8. Oh, you mean like chromium 3 plus?
Yeah.
You just call it chromium 3.
But if it's just an...
That's confusing because chromate is the name for this. This is called chromate, but it's also for this. This is chromate. They're different. So it confuses people.
And then, do you want us to memorize all of the polydentates?
Yeah, there's only 3. Ethylene diamine, oxalato, and ethylene EDTA, ethylene diamine tetraacetate.
Okay. And just so like the formulas or how, like, does that obviously, like I hit the oxalato, ethylene diamine.
Yeah, you don't have to worry too much about it. Ethylene diamine, the EDTA is very hard to buy. They're very hard to draw.
We said yesterday that when we go to do a formula with EDTA, it's like every 2, it's like 1. When you go to write it out.
I don't understand that. Every 2 is 1?
Because it bonds to 8. There's 2 bonding. It bonds
It's a hexadentate. Like
it bonds 4 times.
6 times.
6 times.
EDTA bonds 6 times. Yeah.
electric support hosted by the Trans-Swiss Center. I think it's very competitive and a little support would help.
Yeah, I could do it. What do I do? Just fill this out?
No, I have to fill it out. A friend that went the previous year said that the letter of support that he got from a professor really helped the process a lot.
That's optional on this, or is this
Optional.
This is for the El Camino?
Yes.
Okay. And they give you a little scholarship thing for this or something? Yeah, just give me the information and let me know.
And then also, I'm applying for for an internship with this engineering company called Green Engineering or something. And I think I might also need a letter of support for that one.
Okay. Yeah.
I'll give you the information.
Yeah, give me the information.